Okay, so now let's talk about the thermal stresses in the coatings. So, thermal effects provide important contributions to the film stress. So, typically, coatings prepared at elevated or high temperature, and then they are cooled to room temperature. So, due to this transition, the coating will be thermally stressed. Thermal stress can be evaluated and subtracted from the total stress in order to estimate the intrinsic contribution originating from the growth process. So the substrate is usually much thicker than the film. So thermal stress in the film can be written as by this equation, that is sigma f is equal to alpha s minus alpha f delta t ef upon 1 minus mu f. So here alpha s is the thermal expansion coefficient of the substrate. Alpha f is the thermal expansion coefficient of the film. Delta T is the temperature difference. And we already know that EF and VF are the Young's modulus and the Poisson's ratio of the film. So the question is that what is the most important stress component in PVD films? So in most cases, so PVD films, stress in PVD films. So in the most cases, thermal component are not so important. So thermal component are not so important. Because the deposition process are carried out at low temperature. But we can have significant component due to the intrinsic part. Because we can have significant ionic bombardment, which is typically related to the operating pressure. So if we select high pressure, we have many collisions in gas, and then these energetic particles can transfer the energy to the gas molecules, and then we can attain the low average energy. So the bombardment of our growing film is minimal, and in most cases we have a columnar structure with some residual porosity and typically tensile residual stresses. At low pressure, probability of scattering is much lower, and then these energetic particles will retain the original energy in which the ionic bombardment is significant. And typically we produce a compressive stresses which is caused by the atomic. So the compressive stresses are caused by the atomic peening phenomena or mechanism, we can say. Now, if we talk about the sorry. Now, if we talk about the stress in CVD coatings, stresses in CVD coatings. We know if we don't exploit plasma resistance, the deposition temperature is quite high, which is higher than the 600 degrees Celsius. Sorry. So in many cases, thermal stresses are dominant. Thermal stresses are dominant. So So we can say sigma F is directly proportional to the delta T. So we can have some additional contribution to the total stresses. For example, in many CVD process, we can have incorporation of atoms that are given by the byproducts. So the nature and the magnitude of the residual stress in CVD coatings are primarily a result of difference in thermal contraction between coating and substrate material. Different conditions exist in plasma-assisted CVD process where reactive species are produced by collision events in plasma, and this substrate experience much lower temperature, which is around 200 to 600 degrees Celsius. So in addition, ion bombardment of the substrate can occur during plasma-assisted CVD processes.